bench. Today we have a Sony home theater in a box system, a DAV SB100. And the complaint that I was told that it had before I got it was that there's no sound. Now this is a unit that's got an AM/FM tuner in it, as well as a DVD player, CD player, 5-channel amplifier. It's got your outputs, surround speaker. It's got everything all in one. No sound tells me the problem's going to be in the audio amplifier section. So let's just crack this thing apart and see what's going on in it. Unfortunately, I wasn't given the speakers with it. I was just given the unit itself. But you can use any speakers. They're just 8 ohm speakers. The subwoofer is a 4 ohm speaker, but the regular speakers are 8 ohm speakers. And get this thing going. This thing might replace this unit that I just fixed for my my bench amplifier. But then again, it might not. But it might, because it's got a DVD drive in it that supports MP3 playback. So looking at this unit here, this looks like our amplifiers are here. I've never worked on one of these units before, so I'm just kind of taking a look at it. Looks like this might be, I see a bunch of big inductors here. Right, so I'm thinking that this unit is probably going to be a digital amplifier. It's one of these Class D digital amplifiers, which is not something that I've really done much work on. In fact, I think it's pretty safe to say that I've never done any work on any digital amplifier. So it'll be a learning experience for me too. But yeah, this is definitely a digital amplifier on here. Digital amplifiers are Class D. If anybody's done any research on them, you'll understand they don't operate in the normal manner that a linear amplifier operates in. These work basically on a square wave signal, and how they work is the audio signal is used to frequency modulate a carrier that's typically 100 kilohertz or higher in frequency, and it's a square wave. And they frequency modulate this carrier, and then the carrier is removed through the inductors. These are low pass filters, so they filter out the high frequency component, and you're left with your audio. And the amount of swing, the amount of deviation in the frequency determines the audio content, and the amount of swing is the amount of the loudness. The more the frequency varies up and down determines the amplitude. I'm trying to simplify things because digital amplifiers are not, well, they're not that complex, but they're not simple like an analog amplifier where you can actually just put a scope on it and see it. On these here, if we can get the amplifier working, I'll put the scope on it and you'll see it what looks like a square wave. But first things first, we got to make sure this thing's getting power, because we may have a power supply problem here causing all of our headaches. This is a switching power supply. We have 2 power transformers on here. Just looking at the layout of this unit, got a couple of optocouplers over here, another one over here. So we have 2 distinct, completely separate power supplies. And I'm going to go out on a limb and say one of these power supplies is driving the amplifier section, and the other one's going to be driving the video circuitry and the low voltage stuff. I guarantee you that's how this thing's working. So, to switching power supply, we have to use an isolation transformer just for safety. So let's fire this thing up and get in here with the meter and actually see whether we've got some voltages. So we'll connect our ground probe, or one probe up to ground, just clip it on here to the chassis. set it up for DC voltages and turn on our power. Okay, our power's on. And turn on the power here. Okay, it says hello. So now we can just go through. We know that the low voltage supply is working. We'll be able to see voltages here if I probe run. I don't know if this is a good ground. I don't know if this is isolated or not. So I'm just looking to see whether I've got any normal voltages like 5 volts and stuff. Okay, we got 7 volts there. Check it again here. Yeah, looks like that is probably a good ground. We got 0, 0, 1.8, 0, 0, 4.9, that'll be a 5 volt supply. So we know this power supply is working. Let's go take a look at this other side over here. So we'll just probe some of the pins. 5 volts, 12 volts. Looks like the supply might be working. 5 volts, 5 volts, 0, 3.9, minus 22. We got one of our supplies there. We should have a plus, yep, minus 25. We should also have a positive. We should also have a positive supply there, minus 36. So we know that the negative supply is working. But our positive supply, minus 12. This might not even use a positive supply, but we'll see. Get some zeros and zeros and zeros. There's our positive 31 volts, so there's our positive supply, another 31 volts, another 31. So we've got our power supply working. We've got our voltages coming off of our switching supply for the amplifier. So, the first thing we'll do is we'll hook up some speakers to this thing and see if we can actually get anything off of the radio. Make sure that this thing is in radio mode function. I bet the volume's not cranked all the way up. I don't have any stations programmed into this thing. And of course, without the remote control, you can't tune this thing. You can go through the presets, but without the remote control, you can't tune anything. I can plug headphones in here, see it as well. Let's try that. Let's plug headphones in and see if there's any sound from the headphones. Then we'll try the speaker terminals. Well, we had no sound with the headphones, so I just plugged the speakers in to confirm, and there's no sound whatsoever coming out of the speakers. So the first thing we need to do now is we need to determine whether we've got a signal going in to the digital amplifier. Typically how these things operate is there'll be one of the ICs down there, probably this one here. It's going to be it's a pulse converter. This is more than likely the input, and I haven't looked up any of the specs on any of these, but this is more than likely the input that generates our digital pulse width modulated signal that is then amplified by the output ICs, which are basically just transistors switching on and off. It's a square wave. That's why they're so efficient. They don't need a huge heat sink. They don't need digital amplifiers. Don't produce a lot of heat because they're very, very efficient, and that's why many companies are using digital amplifiers these days, is because they are so efficient. They don't waste much of the energy as heat. So we have to see if we've got a signal going in, first of all, into the pulse width modulator IC. And if there's nothing coming out of this, then of course this isn't going to work. Upon closer inspection of the unit, I find that the DVD drive doesn't open. It says no disk, but when I press the eject button, nothing happens. So we're back to the power supply. We may have a missing voltage. One of these supplies is not working, and that would certainly explain why amplifier and everything else is shut down. We can't even open up the disc tray itself. So I'm just going to take a look at this. There's voltages printed actually on the circuit board here, and just see if we've got any missing voltages, because it's starting to look like we may have a power supply problem. So let's just get the good old magnifier in here and take a look. It says we should have 8 volts on this pin, which we do. We should have 2.5 volts on that one, which we do. We should have 3.3 volts on this one. We have 3.0, a little low. And we should have 5 volts on this one, which we do. So those voltages appear to be okay. So say that one of them's a little bit low here, but the 3.3 is coming up at, what did I say it was? 3.0, and the other one was 2.3, and it's supposed to be 2.5. So we have a couple supplies that are just a little bit low, and I'm looking at this capacitor here. This top looks like it might even be a little bit bulged. So maybe we'll just throw the ESR meter on here and take a look at this. Put the scope on here to see what type of ripple we're getting. See if we're getting any excessive ripple. A little bit of ripple there, not a lot, but well, there is a fair bit of ripple. I'm just scoping the output here of the power supply, and there could be a little bit of ripple in there. Let's take a look at. I'm just going to take a look. That top looks a bit raised, not like the Samsungs usually do, but even this one over here looks like it may be a bit bulged, but this one here for sure. So let's just take a look at the power supply and just see whether we don't have a power supply problem that's creating all of our headaches on this thing. It should unplug from the other board. And the board should lift like that. Okay, now we can take a look. We'll just measure some of the filters on here and make sure that we're not chasing a problem that's caused by a bad filter. So we got the ESR meter out here. Our capacitor that's in question is this one here, C932. That looks like the top could be just a little raised on it. We'll just measure this thing, make sure it's shorted first. And 4.7 ohms. What do you think? You think 4.7 ohms is a little high? You goddamn right it's high. That is off the scale. Let's just pop this capacitor right out of this board here and see, first of all, what value it is, and we'll measure it out of the circuit. But the beauty of an ESR meter is you can measure it in the circuit and it'll tell you right away whether you got a bad part or not. It's out of the circuit. It's a 2200 microfarad capacitor. 2200 at 6.3 volts. Well, a 4700 should be no worse than 0.23, and a 1000 should be no worse than 0.12. So somewhere between 0.12 and 0.23 would be considered to be good. And this is measuring, pointed towards the camera so you can see it, 3.9. Bad. This cap is bad. Let's go find another one. It's a big monster, this one. And it's not, I don't know if you can see it or not, but it might not show on the camera, but that just, looking at the top here, it just looked like it may have been a little bit bulging. And the same goes for this other one back here. This one here looks like it may be a little bulging too. But let's find this cap and try changing this one first and see what happens. And then maybe we'll pull the board out and change that other one. So wouldn't you know, my parts department doesn't have any 2200 microfarad capacitors, but I do have an abundance of 1000. So I'm going to pair all two 1000s together. That should give me a close enough capacity rating to test this thing. And if I was repairing this for a paying customer, I wouldn't be doing it like this. I'd be putting the right cap in it. But this is a learning project to teach you guys how to troubleshoot electronics. So it's just the fundamental of getting this thing working. And if I can make it work with two 1000 microfarad capacitors bridged in parallel just to demonstrate that we've got the problem solved, then that's what we'll do for this demonstration. But if I was repairing this thing for anybody but myself, I'd be putting a 2200. I'd up the voltage a bit from, I think it was a 6-volt one. I'd go to probably a 10 or a 16, just to give me some headroom. But for this will be just fine. I'm just gonna solder the two caps together with a piece of wire, and then we'll attach the wire into the holes on the board, and that should be good enough for this demonstration. So let me get the pigtails on here, and then we'll solder it down and see what happens. So I've tacked in my double capacitor and actually of the disc drawer opens when it didn't before, then we'll certainly know that it's had an effect on it without even having to hook up the speakers. We have power. And let's see if we can open this thing. It says no disc, but the button's not doing anything still. I think we should check the ESR on this other cap at the back here, because it looks like the top is raised on this. I actually didn't even bother to test the other ones. I probably should have tested some of these other ones in here too, because we got one in here that's bad. There's probably others in here. The top on this one looks a bit raised though. So as we look at some of the other caps in here, they're all looking okay. That one looks okay, 0.2, 0.1. I'm looking for something, you know, anything that's really high. 1 ohm, that might be a little bit on the high side. 1.1, 1.4, look probably all okay. Of course, the one I just changed. We'll look at some of these other ones in here too. I want to check this one here on the board. The one at the top looks to be a little bit raised. It just looks off from the way the light's hitting it here. I don't know if it shows up on camera as well as it does to me, but just looking at this one here, maybe not. We tested anyway. Of course, to get in here and actually check anything, you got to pull the whole thing apart, and that includes pulling out the circuit board for the DVD drive, just to get this main board out. These things are certainly not built for any type of serviceability. These things were designed to be tossed in the garbage the first time they acted up. Another 2.6 ohms. Another capacitor that I can guarantee you is bad. Another 2200 microfarad. Let's just pull this one out. I'll put a 1000 in here just to try it. Yeah, 2 ohms. A little high. Looks like water may have also gotten into this, and I see a lot of corrosion. Looks like corrosion around the jacks here. So I'm thinking maybe water's gotten into this thing. That might be why it's not working. But we'll try that. You can see on the screws here, there's rust. If you look on the screws, see the rust on the screw there? So I have a feeling that water got into this unit. I see rust along the tuner. If you look back here, see this? So I think this thing here has probably had water in it. Maybe we can even pop the top off the tuner cover and see inside it. You see a little bit of rust around the edge here. Yeah, it looks like water's been in here actually. So I have a feeling that that's PN101. Somebody's been in this unit. Somebody's been in this unit. Somebody's been identifying the wires. See, someone stuck a piece of tape, PN101. Somebody's had this apart. Someone's been tinkering around in this unit, tried to fix it, and couldn't fix it, so they tossed it out. Oh, it opened. What do you know? Let's just see whether it will read a disc. Well, it didn't read that disc. Now it read it. It appears to be playing this disc. Let's just hook up a speaker. See whether we get any sound. Holy shit. We have sound. Ha 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 ha. There you go, guys. Caps. Couple blown caps. Now I haven't got the tuner plugged in yet, so let's just stop that because I don't want YouTube to freak out because I've got some of the fantasy band with Chuck Loeb playing there for a second. We'll shut that off. I'm just going to reconnect this tuner module. I'll phone this guy and say, hey, you got the remote control for that thing by chance? Okay, we'll power it back up here. We'll turn it on and we'll just see if the tuner will function. Nothing on the FM band. Let's try the AM band. I think maybe the tuners maybe got wet. So we'll switch it back to CD, DVD, and open it. Load up a DVD, and we'll just grab the monitor. We'll see if we get a picture. Looks like it plays. Once again, I don't know if I'm able to play this thing. Maybe I can. Maybe it will play without the remote. Can't do much else without the remote, but see if it will continuous play. Sounds like we got sound. I only have one speaker hooked up. We can hook up the other speaker here. Just hook up one side of it. I just have to make sure that I get the right one. I don't want to short it out. We could have major sparks. Yes. It is working. So the CD player and the DVD player of this unit now is working. I'm just going to take the camera off that because I don't want to annoy anybody at the YouTube. So there we have it. We got this thing going. We had a couple capacitors that were blown. We had one on the power supply here that was foobarred, and we had another one back here that was shot. We still don't have the radio working. I'm going to work on that a bit here and see if we can get sound to come out of the radio. Well, we have noise on FM and AM. I just took the tuner assembly out and I cleaned some crap that was in here around the edge of the board. Just scraped it out with my fingernail. There's a bit of rust in there. Yeah. Now, if only we had a way to tune this thing. But it appears to be working. I only have 2 speakers hooked up to it, but hey, we solved the problem. We fixed another one. I saved another one from the landfill. But the thing is, I don't have the remote for it. We're gonna have to find that, or find a remote that will work it at least to set the radio stations. Maybe a universal remote. I might try. I've got a couple of universal remotes here. I may try programming one of those up and see whether I can use that to control the tuning. In fact, we'll try that right now. I gotta love these the original TELUS remotes. I've got a couple of them that were discarded because the volume buttons didn't work. And I've, of course, since repaired the volume buttons on them, so the volume buttons work on them now. But I really gotta like these old ones because they controlled so many devices, including this device here. Not only that, I can even tune the radio and I can search. I can search the radio stations. Alright, I like it. This thing works. I hope you enjoyed this video. I'm going to put this thing back together and gee, I think that I'm going to I got 2 of these remote controls here. They use different codes. So I'm going to put this thing back together and find something to do with it. Be nice if I had all the speakers with it, but you know, speakers are speakers. I can certainly put any type of speakers on. They're just 8-ohm speakers, so no worries there. Hope you enjoyed this video, and we'll catch you in the next one. Ruby, you got your little stuffy?